Homework 2.3, Linear Functions and Slope, Video 10. Homework due Friday, May 22nd, 2020 at 11:59 p.m. This is the last video in the series. Hooray. And it's kind of like the previous video about graphing general form, but this time instead of graphing general form using slope-intercept form, we're going to graph general form using just intercepts. Now, the y-intercept gets a lot of play because it's the intercept in slope-intercept form. But the x-intercept kind of just sits in the back and says, what about me? Well, the x-intercept is just as important as the y-intercept. It just doesn't occur in slope-intercept form. Now, look, throughout the rest of the course, when we start graphing more complicated functions beyond linear, so things that aren't just lines, we will consistently be focusing on intercepts, on both y-intercepts and x-intercepts. So this is the first foray into how to find intercepts in general, but I promise you it will not be the last. It will be a very recurring theme. So we're going to graph x plus 4y equals 10 using intercepts. Now we know this is a line. We could solve for y and it would be in slope-intercept form, so it's a line. And so we really only need 2 points, so why not the intercepts? So how do you find intercepts? Well, let's think generically for a second. Let's say I have a line that's neither horizontal nor vertical, so that it has both an x-intercept and a y-intercept. What can you tell me about this word pair? Can you tell me anything about its y? Well, based on the way I drew this one, you can say its y is positive, but you couldn't tell me its value. But can you tell me something about this point's x? I'm on the y-axis, which means from the origin I did not go left or right, which means my x-coordinate must be 0. So one thing that all y-intercepts have in common is that the x is equal to 0. So the generic way to find the y-intercept, it's a 2-move process. Let x equals 0, solve for y. Well, that's not that bad. Guess how we find the x-intercept? Same way, but the opposite. Because if you're an x-intercept, then I know something about your ordered pair. I may not know something about the x. In this particular picture, the x is negative, but that's all I can say. However, because this is on the x-axis, it did not move up or down, which means its y-coordinate must be 0. So in general, to find the x-intercept, you let y equal 0 and solve for x. And again, this will be a very recurring theme. Every time we look at a new type of function and start graphing it, we will consider intercepts, and we will always spiral back to this. The easiest thing to remember is to find one intercept, you let the other letter equal 0. To find the x-intercept, let y equal 0. To find the y-intercept, you let x equal 0. So let's do that on this one. Let's start with the x-intercept. For the x-intercept, we would let y equal 0. So if we let y equal 0 in this equation, we get x plus 4 times 0 equals 10. But 4 times 0 is 0. And if you really want to subtract 0 from both sides to cancel the 0, be my guest. But adding 0 to something doesn't change it. X plus 0 is just x. I see that on papers and I kind of giggle when I see it. They subtracted 0. Oh look, our x-intercept is 10. That means when I go to sketch this graph, I will go to 10 on the x-axis, put a dot. And now let's find the y-intercept. To find the y-intercept, you let x equal 0. So if we let x equal 0, we get 0 plus 4y equals 10. Again, you can subtract 0 from both sides, but you're subtracting nothing. 0 plus 4y is 4y. Excuse me. Divide both sides by 4. And we get y equals 10 fourths, which reduces to 5 halves. Now, because I'm locating on this on a graph, I think I would like to turn this into a decimal just to get a decent approximation. But half of 5 is 2.5. So our y-intercept is at 2.5. So I can sketch this graph real easy now. All I need is to count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 on the x-axis. 1, 2, 3, 2.5 is halfway in between on the y-axis. Bada bing, bada boom, bada done. Now, this can be done even faster if you can do what I call the cover and think method. The cover and think method means that you cover part of the equation and you think. For example, for the X Intercept, let's do one from scratch. That didn't take very long. This is probably on the 4-minute mark if it's even that far. Oh, okay, 5.5 minutes. But it's the last video and it's only 5 minutes and 30 some odd seconds into it. So let's do one more, but I'm going to show you the cover and think method. For online homework, this is pretty nifty because it requires almost 0 writing. But for a test, you'll want to write it down. Oh, by the way, this will be in the announcement about the test, but when you take your tests, I will ask you to write everything down on paper and send me pictures of your work because no scratch work means no points. So it is important to write things down. Your goal is to convince me that you get it. Let's try graphing this one. Let's graph 2x minus 3y equals 12 using intercepts. But I want to show you how to do what I call the cover and think method. To find the x-intercept, we let y equal 0. But if we let y equal 0, this term will vanish. So let's just cover it up. And now it says 2x equals 12. How do you solve that? Divide by 2 and get x equals 6. X-intercept. Same thing for the y-intercept. You let x equal 0, which essentially annihilates the x term. And now we have negative 3y equals 12. And now think. Divide both sides by negative 3, and you get y equals negative 4. I give general form a hard time because it doesn't contain any information. Its goal is to look pretty. And although this technically isn't in general form because it's not equal to 0, it practically is. But one thing it does do that makes graphing easy is locating intercepts, especially when you do the cover and think. Cover the y, get x equals 6 for the x-intercept. Cover the x, get y equals negative 4 for the y-intercept, and just like that, you got the graph. So it's pretty sweet. All right, that concludes this video series. I know this doesn't matter, but I'm looking at my watch. It's 4 p.m. I think I'm going to go ahead and start one more series because I know it's pretty short. Oh, one more thing. In the homework, the graphing general form via intercepts is questions 23 and 24. There is a question 25 in the homework, but I like putting problems up there that I don't specifically show in the videos to get you to think and to reach out for help.